Hey guys, now we're gonna learn about the limits of accuracy. Okay, everyone, please sit properly and pay attention on the screen that you already see right now. Okay, so whenever we are talking about the limits of accuracy, we are talking about the measurement. Okay, what is measurement? You measure something with the measurer tools. Anyone? Do you have anyone have 30 centimeter ruler? 30 centimeter ruler. Do you have 30 centimeter rulers? Please come. I want to borrow. Okay, please borrow 30 centimeter ruler. Anyone? Sorry, Regina. I borrow your ruler. Okay, thanks. So anyway, this. Okay, listen, please. This is the ruler, and the ruler is to measure the length of a certain object. For example, I want to calculate the length of the book. Okay, if I want to calculate the length of the book, okay, listen and see here. I need to put the zero in the first place in the edge of the book, and I will need to make as straight as possible to measure the other part. Okay, as you can see, if you want to try to do that as well, the length of the book is about here. If you can see it at home, and if you can measure it yourself, it is about 25.4 or 25.3, depend. Okay, is it 24.5? In this calculator, 25.5. Okay, so the length of the book. So if I want to draw here, look at the screen. Yeah, I'm not drawing it so good. It's a bit miring. Okay. On the edges, yes, that's right. So the length of the book here is about 25.4 centimeter. So we know that this ruler has the degree of accuracy of 0.1 centimeter. Get the idea? So the degree is 0.1 centimeter for each of the dots here. Okay, 0.1 centimeter. And I want to calculate the breadth or the width of the book. So if I want to calculate the width of the book, it is about 17.3. It's about 17.3. Okay. But the question is this number is very accurate or not accurate? Is it 100% accurate or not? No. No, yeah. So this is not accurate. So we have to admit that our calculation has a certain sort of error. It might be wrong. But how the tolerance will be? Okay? The tolerance means the range of the value. We are learning about later upper bound and lower bound. Okay. What are those? What are upper bound and lower bound? Okay, listen. Upper bound is the maximum allowance, the maximum range of the length of the book or the dimension of anything. It might be not only length, it can be seconds using your stopwatch. Okay, if you do the stopwatch, if you use stopwatch, you know what is stopwatch, right? You can measure it in a certain limit of accuracy. It will not be exactly the time, right? But it shows you the time when you press the stopwatch, right? Not always, if you press anything, if you press the light, you press. You have the limits of accuracy as well. Okay, not only length, it can be mass, it can be temperature, it can be time, it can be distance, anything. Okay, next. So when we learn about the upper bound and lower bound, we have to know that the 25.4 is located through a certain position. Not only 25.4, but also 17.3 as well. Okay, it might be located on a certain position. Okay, located at a certain range. Here we call it as a range, the limitations. Okay, it can be more or less. Look at this. It can be more than 25.4. It can be less than 25.4. It is called upper bound for the more, lower bound for the less. Okay, the less part. Okay, next. What are they? Any measurement that we make is rounded to some degree of accuracy. So we have the degree of accuracy, the level of accuracy. Okay, accuracy 100%, nothing. You have no 100% of accuracy. It's totally misleading. So the accuracy might be less than 100%. It might be 0.1 centimeter as it is given on the ruler, and we have more accurate tools. It is called vernier caliper. If you learned about that previously in science, haven't? Okay, and also we have the other measuring tools. It is called micrometer screw, protractor, also degree angle, right? Anything that you measure has their own accuracy. Okay, to the nearest meter, for example, to the nearest liter for volume, right? The degree of rounding gives the possible values of the measurement before you round the number. Okay, so again, this is still on the estimation chapter, but not in your book. This is extra. Why? Because this is what we usually use in our daily activities, especially for estimating something, right? Next, for example, a lighthouse is 76 meters tall, measured to the nearest meter. Okay, pay attention. This we start the number here. So it is 76 meter. It might be more, it might be less, right? Depend on the accuracy. To the nearest meter. So we know that to the nearest meter here is the accuracy. So the maximum error, or sorry, the minimum error is 75, okay, and the maximum error is 77. But again, to the nearest meter, you need to make it half. You need to half it. So what is the number here? Oh, here. Yeah, 76.5. How about this? So this is the range of error. Okay, 76 go up by 0.5, go down by 0.5. It can be 1 on the accuracy, right? So this is the limit of accuracy. So this is the accuracy of the lighthouse, or not the lighthouse, the measurement of the length of the height of the lighthouse. Okay. So, yep, there you go. So this is the least possible value, 75.5, and this will be most possible value, 76.49999, or it can written as 76.5 also. Yeah, rounding. Next. So that's the limits of accuracy. So this is the repeating what I write just now, what I have written. So the length or the height of the lighthouse is in between 75.5 until 76.5. And you need to memorize. Here. We have equal sign here on the left side. We don't have equal sign on the right side. Only for agreement. Okay. Agreement that the left side has equal sign, the right side has no equal sign. Okay, this is the height. You can just write H. And then this is 65.5, and this is 76, 70, 75.5, and 76.5. Any questions so far? Yes. No negative, no positive. It's everything. Everything is positive. Equal sign. Yeah. The left side has equal sign. The left side has equal sign. The right side has no equal sign. Make sure that you do this right. Why? This is for your scientific measurement. Okay, so we are talking about the scientific measurement. You measure the right, you measure it right, and you have to write it right also. Okay. Next, for example, a car is 2.6 meter long, measured correct to 1 decimal place. So 2.6, it is in between what and what? 2.5,
2.5 and 3.
right? Because
Yes.
so what is the middle here? Yep,
2.55.
there you go.
2.65.
Oh, 6.5. Okay. So the range of the car is 2.55 less than equal to the length, let's say length here, and less than 2.65 meter. This is called, the lesser one will be called the lower bound. The smaller part called lower bound. The greater number will be upper bound. Okay, that is the way you understand what is upper bound and lower bound. Let's try to look at the explanation. So let's check. Do my explanation is right? Is my explanation right? I think it's right. So in between 2.5, okay, pay attention, and 2.7. In between 2.55 and 2.65. And this will be the limit of accuracy, the blue color. Okay, the 2.55. See, it's the same, yeah. Not height, it is length. The length. Height means vertical, length has to be horizontal. Okay, that's for the example. There you go. So we did everything right. Now, the harder part is the problem that it involves the limits of accuracy materials. Okay, when we calculate an area or a volume or a speed or anything, we need to understand that the error will be greater. Okay, there will be a greater error when you calculate two errors, right? Length times width, both of them has limits of accuracy. For example, this book. Okay, look at this book. I have the length of the book with a certain limits of accuracy, and we have the width or the breadth of the book that also has their limits of accuracy, right? Both of them you operate, you multiply, you add parameter, and so on. You have to understand that it will make the error greater. Okay. Next. For example, a room is measured by 6.4 times and 4.3 meter. Okay, measured to the 1 decimal place. A room. Okay. For example, this. I will give you the explanation right now using this. Okay, see my explanation well. Okay, please pay attention. A room. What is the size of the room then? 6.4 and 4.3, right? So 6 times 4. What is the shape of the room? Any guessing? Rectangle, of course, right? No, no such things like square. Square, it has to be same, right? So write down this, okay, as not in scale, not to scale. So this will be 6.4. Okay. The length is 6.4 meter, and the width or the breadth is 4.3 meter. Okay. Calculate the area. So how do you calculate the area? The area has to be understood by using the limits of accuracy. So you cannot just 6.4 times 4.3, length times width, totally wrong. Mathematically, it's right, but if you are calculating the limits of accuracy, if you are trying to find the accuracy, you need to understand that the length and the width has its bound. There will be the boundary. Okay, so 6.4, the length is located in between 6.3 and 6.5, right? Get the idea, guys? And the width, which is 4.3, in between. Okay, so what is the limits of accuracy, or what is the lower bound and upper bound? Wrong. 6.35.
35.
Be careful, not 6.3, yeah? So the upper bound will be
6.5. 6.5.
4.5. Get the idea, guys? Not 6.3, not 6.5. 6.3 and 6.5 is only for the easiest part. Look at this. Okay, in between 2.5, in between again. So half of it. Get the idea, guys? So this is the lower bound of the length, and this will be the upper bound of the length. YOW, UB. Okay, and then look at the width. In between, so this is the regular calculation. In between 4.2 and 4.4, what is the middle? 4.25 and 4.35. So first thing first, what you need to understand is to know what is the lower bound, what is the upper bound. Okay, let's see one more time, guys. One more measurement. 205. In between, what is the smallest possible value?
204.
M.
206.
Okay, the upper bound will be
204.5. Or the upper one. 205.
okay, no, up to you, no problem. 204.5 and 205.5.
205.
Get the idea, guys? I will give you the easiest way to do. Look at this. Look at this properly. 2000 to the nearest 10. So located in between 190, right? Now it is nearest 10.
Oh yeah. 190 to 2010.
What is the lower bound?
1995.
And
2005.
this is the lower bound and upper bound. You cannot directly say this as the lower bound. Totally wrong. Do you understand so far? Any question regarding to the upper bound, lower bound? Who is still not understand? No problem. Just be honest. Okay, anyone that has that still don't understand about this? No one? Okay, good to hear that. Let's see. Nearest 10, be careful about the nearest 10. Nearest 10 means you have to subtract 10 and add 10, and then you find the middle. Okay. Now, we are not done yet. So what is the area? Limits of accuracy of the area. So the area also has its formula, right? Length times width. But it is asked in terms of the limits of accuracy. Let's see. So we have area. I want to find the upper bound, right? So the length of upper bound times the width of upper bound. Understand, guys? So we are calculating the maximum area. Okay, upper bound means the maximum. So you need to multiply the maximum amount of length and width, right? So I will put it in a yellow highlight. Maximum area is the length of the maximum, right, times the width of the maximum. There you go. Then what next? You multiply, right? 6.45 times 4.35. Anyone that has calculator, please calculate it for me because I don't bring my calculator right now. 0. Okay, so what is the answer then? You can round down, or you can round the number, round off the number. You can put 1. You can put 0.6 also. Both of them are same. I put 0.6, more accurate, right? It's still simple. And how do you calculate the area of the minimum? You find or you look at the minimum amount of the length and the width, right? This one. Wait, it's the same. I use the blue color, but I use the blue. There you go. And there you go. So you measure the answer, you calculate the answer. 6.35 times 4.2. Sorry? 98? Sorry? Okay, 9875. So you can round off the number by 28.99 meters squared. Do you understand so far, guys? So you do the calculation with calculator, of course. I'm not asking you to do it manually. If you do it manually, I think it is unfair, too much. Okay, we are not focusing on the mental math right now. And then, wait, one more. So calculate the limits of accuracy of the area. We get the maximum and minimum area right now. And what is to do next? What we have to do next? Wait, there you go. So there you go, a minimum area. And you need to put it on the limits of accuracy. Wait a moment. So there you go. Is this? Wait, new. So the area is located in between 26, yeah, guys. I did something wrong here. 26.99 until 28.06 of 0.06. Okay, that is how we do the calculation, the limits of accuracy. Okay, so again, you cannot just directly put 6.4 times 4.3 area. Wrong. You need to find the upper bound and lower bound of each of the units first. Any question, guys, so far? Still simple, right? It's not very hard. It's hard, but doable because you have a calculator to help you to do this easily. Okay, I'll put on Microsoft Word, and then I have one more questions, and then we are done for the materials, not for the exercise. Exercise will be given later. Okay. Next number. Let's see again. The display has to be duplicated. One more, guys. Bertahan. Don't get sleepy yet. It's the same, right? See, every working out is the same. 6.935 and 6.45 for the lower bound and upper bound. They just put it on the range. 4.25 and 4.35, easy, right? And the minimum area. So this will be the minimum. Why? Because they took all the minimum, right? 6.35 and 4.25. They took all the minimum. The answer will be here. It's the same, right? 26.99. And to calculate the maximum area, they pick the 6.45 and 4.35. Let's see. Yeah, there you go. Okay. And then you find the maximum area, 28.06 to the nearest meter, to the nearest two decimal place. And the limits of accuracy, that is same. Right? Everything we are done are the same. Oh, there you go. Val, with Val. The guy that has long hair and is running. He states that he can run 400 meters in 44 seconds. Both this measurement are given to two significant figures. Find his maximum speed. Okay, let's do. Okay, guys. So be careful about this. I want to delete the guy. Important. Okay, so 400-meter race. So the distance, right? The distance is 400 meters. And the time is 44 seconds. Right? As I just write as better. And I will put the distance a bit on the right side. Both of this measurement, careful, correct the two significant figures. You stop the zero here, right? Remember the significant figures rule? 2. Yeah, and then time also, time 1, 2. Okay, so you need to understand that this is to the nearest 10. Oh, nice. Very fast, Jones. Nearest 10. Why? Because the significant figure is located here. Okay, so the range is in between 390 and 410, right? And you are picking another middle, another mid part of it. What is it? 395 for the lower bound for the distance, and 405 for the lower bound for upper bound for the distance as well. Also, okay, write down. So we have distance, and we have the upper bound. Wait, upper bound and lower bound. LB and UB. Yeah. So the upper bound for distance is 405, and the lower bound for distance is 395. And now we are calculating the time. So the time, all are significant figures, so to the nearest one. Right? So it is in between 43 and 45. Get it? So what is the middle number? 43.5 and 44.5. Easy peasy. Right? 43.5 for 4.5. Okay. Seconds. Oh, no need. Just write it down here. 43.5. The question is asking you for his maximum speed. Do you know what is the formula of the speed, guys?
Distance divided time.
Any other answer? Yeah, distance over time.
Different. Oh, yeah.
Over distance divided by time. Now, okay, the hard part will be given right now. Please again pay attention. Okay, this is harder one. In order to find the maximum speed of maximum, what you have to do? The distance is supposed to be upper bound, right? As much as possible, right? So the distance of the maximum over the time, maximum or minimum?
Minimum.
Why minimum, Jacob?
So you can get if the time is less, then you know you can get there at a faster time. So the speed will be quicker.
Okay, good explanation, but I want to repeat one more time. In order to find maximum speed, means you go very, very fast, right? If you go very fast, the time will be less or more?
Less.
Time will be less, so it has to be minimum. Make sense for you? Anyone that has that's still confused? Here, to find maximum speed, the distance supposed to be more and the time supposed to be less as less as possible. Okay. So the distance of the maximum part is the upper bound of the distance, 405. It is given here over the time. Here, 43.5. Why? Because you are finding the lower bound of the time. Okay. And vice versa, if I switch the question, how about if I want to find the minimum speed?
The distance is minimum.
Yes,
The time
distance
is
minimum, and the time has to be maximum. Longer time, less distance, right? Time maximum. Or you can just write 305 and 395 over 44.5. Right? Yeah, there you go. This and this. So it is division, not multiplication. If it is multiplication, just everything is maximized, right? Okay, calculator, please.
9.4.
Okay, 9 point. Okay, thank you. I just write like this. Yeah, 9.3 is okay, or 3.1 is still okay. Meter over second for the answer for the maximum speed. And again, if I ask you for the minimum speed, what is the answer then? Okay, please calculate. Okay, that's it, meter over second. Okay, wait. By the way, the red color here is the question that I improved, right? So this is the improved questions. Okay. Again, the actual question, actual answer is here, 9.3 meter over second. But because we are finding the maximum speed, okay, only maximum. If I ask you the minimum speed, you can also do it, right? Okay, I'll send this to you. See, 9.3, it's the same. Maximum speed is greatest distance and shortest time. And then what else? We are done actually. Okay, we are done for the explanation, but I will give you some exercises. Let's see.